Okay, now we're looking at case 2. And guess what case 2 is? You'll be having the product of, yes, of course, two different functions. But you'll be having an algebraic term and the trig function. So the first one we had algebraic and exponential. Now we have algebraic and trig. Wow, really? Yeah. So in this case, either it's algebraic, of course, it's the algebraic raised to the power of n, because it's what is going to be the u. So it is what is going to determine how many times we do integration by parts. Because we're going to integrate by parts until the variable disappears. And it's going to, if it's raised to the power of 8, we'd have to integrate by parts 8 times. Wow. So yeah, because it's the u. And now what's going to happen is, you see, it can either multiply a cos x, or it can multiply sine x. It doesn't matter. Okay, the formula changes only slightly, but then the way we find them is different. So you'd have to know how to. The first thing we'll be doing here is how do we get to the reduction formula. Then now when we have the reduction, because they might ask you, okay, show how or show that the reduction formula, or yeah, find the reduction formula of x to the n cos x, right? And you'd have to know how we get there. So we're going to do that first. And then we'll do that for sine x. We find how we get there. Now, when we know these two reduction formulae, then we can now use them in some examples, okay? Because they could give you examples where you actually want to use them instead of develop them, all right? So let's develop. In this video, let's develop for the integral of x to the n cos x with respect to x, okay? Here we have this, and of course, now we are saying this is going to be our in, okay? Is the integral of x to the n cos x dx. Now, we know that when we are developing this, guys, we use integration by parts. We use integration by parts to develop because it's actually an integration by parts question, okay? And it helps us to get to the formula. So let's do integration by parts. So if I were to integrate x to the n cos x with respect to x, right? I would say let u be, remember the integration by parts formula, what does it say? It says the integral of u dv is equal to uv minus the integral of v du, right? Okay, so here I would say let u be equal to, of course, the algebraic term, x to the n. We said u is always the algebraic term unless it is met the logarithmic. So here that means my du dx would be equal to n x to the n minus 1. And that means my du is equal to n x to the n minus 1 dx. And I know my dv is equal to cos x. My v would therefore be equal to integral of cos x with respect to x, okay? And that would mean that my v would therefore be equal to, what is the integral of cos x with respect to x? It's just sine x, okay? We don't add right now, we don't add that c right now, okay? Not now. Or you can say your dv is cos x dx, and then your v is that integral. You integrate both sides and you get your v, right? So that's this cos x dx would be my dv, and this would be my u, okay? So if I integrate, I know that I integrate dv, I get v. I integrate cos x with respect to x, I get sine x. All right? So now what am I going to do? Well, I can now replace. I'd say that the integral of x to the n cos x dx is equal to uv. What is u? Is x to the n. V is sine x, so x to the n sine x. And then minus the integral of v. What is v? Is sine x. Multiplying du. What is du? Is n x to the n minus 1 dx. Okay, and what are we going to do now? Well, we can tidy it up. We can say the integral of x to the n cos x dx is equal to x to the n sine x minus, we take out this n, so we take it out, minus n integral of, here we now have x to the n minus 1, okay, multiplying sine x dx, okay? And here, are we done? No, we do by parts again, okay? We do by parts again for this one. So we can isolate it and work with it. The integral of x to the n minus 1 sine x with respect to x. You say this would be your u, and this whole thing would be your dv. So let u be equal to x to the n minus 1, and let dv be equal to sine x dx. That means v would be equal to the integral of sine x dx. And that means du would be equal to, the power comes down, n minus 1, and then x to the n minus 1 minus n minus 2. Okay, we reduce that by 1. Now this would be, what gives me sine x? It's negative cos x dx. The dx is gone now. So it's negative cos x. We don't add the c right now, okay, because we're in the midst of doing something. Now, that's my v. And I can apply it now. I would say, all right, so the integral, I can bring everything back, of x to the n, this one, cos x dx would therefore be x to the n sine x minus n multiplying. Here, remember, we said integral of u dv is equal to uv minus the integral of v du. So, what is my u? My u is x to the n minus 1. What is my v? Is negative cos x. And then minus the integral. What is my v? It's still negative cos x. Then what is my du this time? My du is n minus 1 x to the n minus 2. Okay? Okay, now we can, and here, this is the integral of that. Remember that this was du dx, so that means du is n minus 1 multiplying x to the n minus 2 dx, okay? So here, don't forget that dx is with respect to x. Integral, therefore, of x to the n cos x with respect to x is equal to x to the n sine x minus, here I can see that I can leave it like that first, x, and then I simplify. Okay, negative cos times that is negative x to the n minus 1 cos x. Then minus becomes plus, so it will be plus the integral of cos x multiplying n minus 1 x to the n minus 2 dx. And I see that, okay, this n minus 1 is a constant, I'll throw it out. So therefore the integral of x to the n cos x dx is equal to x to the n sine x minus n for now, minus x to the n minus 1 cos x plus the integral. Oh, before we put the integral, we take out the constant, which is n minus 1 now. So plus n minus 1 here is out, the integral of x to the n minus 2 multiplying cos x with respect to x. Okay, and that's how it is. Okay, so if we want to expand by this negative n, we would have therefore the integral of x to the n cos x with respect to x is equal to x to the n sine x minus times minus becomes plus, so it's plus nx to the n minus 1 cos x. Then minus times plus becomes minus, so it's minus n multiplying n minus 1. Okay? And this is times the integral of x to the n. Let me write it better. The integral of x to the n minus 2 cos x with respect to x. You say, why did we integrate up to cos x? Why did we get up to here? Because if you check, this integral that has a cos x inside is related to this one, which also has a cos x. We couldn't stop here where we had a sine x. Where was it? We couldn't stop after the first because we didn't have that integral of that form, of the form cos x here. We had a sine x. We couldn't stop here, all right? We had to put it until they're in the same form. And then now we can say let in, we already know though, but we can just write it now, be equal to x to the n cos x with respect to x. That means that wherever there's this x to the n cos x dx, I put in. So now I can safely say in is equal to x to the n sine x plus n multiplying x to the n minus 1 cos x minus n multiplying n minus 1. The integral now, the integral of x to the n minus 2 cos x is just in minus 2. Because remember, the integral of x to the n was in. Integral of x to the n minus 2 is in minus 2. Wow, really? Yeah, and this will be the end. That's just how you do, and you can remember this. Okay, you can. We'll check how to develop the one for sine. But it'll be very much they'll be the same. So when in is x to the n, when you have in being x to the n cos x, okay, the integral of x to the n, because I is integral, you know that. So in is when it's the integral of x to the n cos x, then your formula would be x to the n, but instead of writing cos x, you write the integral, which is sine x. So it'll be x to the n sine x. Then what do you add? You add the derivative. Okay, that's kind of what we say. You add like the derivative of this guy. Okay, the derivative of this guy as a product rule. So it's going to be, you know that my derivative. So it's like if we talk about this, I'm going to multiply this by the integral of this, okay, which is here. Then I add the derivative of this one now, which is n to the n x to the n minus 1 multiplying cos x. Then I subtract this n by n minus 1, in minus 2. I don't know if you remember that. So if I'm writing, I have in being equal to the integral of x to the n cos x dx. This is the thing you're going to do. You would have realized it in a question that, wow, I have x to a large power and it's multiplying cos x, right? Now, I want the formula. In would be, what did we say? We said when we're in, first thing we do, we bring the x to the n as it is when we integrate that, okay? Integrating cos x is sine x. Okay? Then we add that to the derivative of that guy. So n x to the n minus 1 multiplying cos x. Then we subtract n by n minus 1 of in minus 2. Okay? Kind of, I don't know how you're going to remember it. You can remember it by saying it's product rule. Okay? You're going to do product rule, but keep the first two terms positive. Okay? Product rule. It's another thing. You can do that. But the reason I said keep the first two terms positive is that if we do product rule, cos would go to negative sign. So it would be tempting to put a negative here. But it's a positive. So you can do the product rule, but remember to keep the first two terms positive. In your product rule, remember to keep all the terms positive. Okay? So in other words, what you're going to do is, in the product rule, you'd say, okay, I keep the first one as it is, I differentiate the second one. Derivative of cos is sine. Instead of negative sign, you just write the sign. Then plus, you keep the second one as it is, cos x is as it is, then you differentiate this one. It will be n to the x, whatever, x to the n minus 1. Then you now subtract this part, just remember, n by n minus 1, I to the n minus 2. At that other one, we add for sine, you see that it's going to be similar, just the same thing again. Okay? So remember that. That's just a way of memorizing. You'd have to find a way of remembering. And this is the way I would recommend you to do it. Okay, goodbye. Thanks for watching.